RavenDB is a NoSQL document database. So what actually gets put in the database is a whole bunch of documents. Each document is basically JSON. Each document has an ID, which is a unique way to refer to it, and then it's just a JSON thing. RavenDB has a really nice API for you to talk to it from C#, and it's got all the features you'd expect of an ORM. So if you're familiar with some kind of ORM, it does loading and saving and entity tracking and that kind of stuff. It does all of those. So one of the cool things about Raven is just how easy it is to use. So this is all it takes to add a new document into the database. So feed is just a plain old C# or plain old CLR object with a whole bunch of, say, properties. And then we create the object, we give it to Raven to store it, and then we atomically commit all the stores that we've done already, in this case just one. And that save changes is an asset transaction at the bottom. The way that feed gets serialized is it uses the JSON.NET serialization library. So if you want, so chances are the default will work, but if you did want to customize how the serialization works, you can do that. So we do that in a few places to serialize things slightly differently from the default. Having stored a document, it's really easy to get it back. Each document has a unique ID referring to it, and session.load, you just give it the unique ID, and it gives you back the document. And it does all the deserialization back into that plain old C# object again for you, and then you can just you're back to where you started. So that's putting things in, and that's getting them back. Having got them back, you can then just change the properties as you normally would, and then you just do session.save changes, and it will save any properties that you've edited. It does entity tracking on the properties, so it knows which things you're changing. So really easy to save things, really easy to get things, and having got things, you can just update properties and call save changes, and they'll go back in. So what happens if you don't want to just get things by IDs? What happens if you want to do kind of more complicated queries? So Raven supports all of that as well. So this is a query for RavenDB. So you'll see that it's got to list twice in this. So everything up until the first to list are expression trees that get run on the RavenDB server. And then everything after the first to list and before the second one are executed on the client, in the C# process on the client. So what this means is that you can do all the where clauses on the server, you can do all the sorting on the server, and that just all gets done for you. And then once it's back on the client, you can obviously interact with the rest of your code that wouldn't be accessible from the server. In this case, we're just using a really simple index, which is just the feeds pre-sorted, but it also supports the full power of MapReduce indexes. So you get anything that you can do in MapReduce as an index. So one of the great things about Raven is that it's designed to change how you work for the better. So if I'm writing a website and my web page turns out to be slow, one of the reasons why it might be slow is I'm just doing too much work to the database. And Raven makes that impossible, and instead it will throw exceptions, which the idea is that you catch those exceptions during development and you fix your app to not hammer the database as much, which gives your users a better experience. So to do that, it caps the number of results per query, it caps the number of queries per session, it caps the number of sessions per web request. And what that means, all those three things combined together, means that essentially it caps the number of results per web request to about 30,000. So you can only access at most 30,000 things from the database in each web request, and chances are you're accessing a lot less. So let's say that you love what you've heard so far and you want to switch to it, just like so the history of deployment manager is that it used to be written on top of a SQL database, and it got switched over to using a RavenDB. If you have a SQL mindset and you just blindly switch over to a document database, it doesn't matter which document database you pick, whether it's Raven or Mongo or one of the other ones, you'll have an awful lot of bugs from null reference exceptions. So in SQL, you can have foreign keys between tables, which means that it's guaranteed that there'll be a record over there for you to go look at. In document databases, there aren't any foreign keys. So if you assume that you can just go ahead and load a document over there with the ID that you've got in this document, it may not be there, which will cause a null reference exception because the load will fail. So you need to think very carefully about your schema, even that kind of how many documents you're having, what their contents are, how they relate to each other. Because if you're not careful and you don't think about it, you'll get lots of null reference exceptions. So that's document databases as a whole. RavenDB has a few particular issues that just this has. So all of the indexes have eventual consistency. So what that means is that whenever I run one of these MapReduce indexes here, it will eventually be consistent, but maybe not right now. So the places this tends to hit us is on some kind of, let's say there's a form on the website that lets you create a new thing. So you type in all the details, and then you press the post button at the bottom. The form gets posted off to the server. We create a new document in the database. We then issue a HTTP redirect, sending you back to the index of all the things. The browser then requests the index of all the things. The database then uses an index to get the list of the things, and it sends back to the browser the list of the things. One of the things that we've suffered quite a few times in Deployment Manager is that we have the UX issue that the thing the user has just added isn't in the list they get back because of the HTTP redirect, it comes back in on a different session to the database, which isn't guaranteed to have all the saves that have been done in previous sessions just yet. So the indexes are out of date. If you load documents by IDs, it's fine, that's guaranteed to work, but because the indexes are updated lazily in the background, it depends on the load on the server. There are magic things you can put in your code to say wait for the indexes to be updated, but you may end up waiting a while, which may time out the request and how many indexes there are to update. So you can get lots of user experience issues of just things that the user has just created aren't in the list, which is very confusing. I've made this feed, why isn't it in the list of feeds? And you can have lots of 404s if you take keys in the URL and do and do queries based on those keys. Those objects may not be there. So the answer is always to use the ID, but we haven't done that consistently everywhere. So this is something to bear in mind. Cool. And now we're coming on to a demo.
So David, you're about 7 minutes in. So.
Awesome. So the demo is really fast because it's just a bug. So this is what eventually consistent looks like. So here I have an index, and my query is where the name property is set to this, and the state property is set to this. So let's just go ahead and click the execute button. So that's the index, and this is the document we get back. And you can see the document we get back has got the name, check for updates, and it's got the state success. So this is the document itself is up to date, but the index is not. So when I query the index, I get the wrong result. If I go ahead and look at the document, you can see that the last modified date is the 12th of September. So it's eventually consistent, it just hasn't got round to updating in 2 and a bit months. And this caused the bug. So the way we do check for updates in Deployment Manager is we have one of these tasks that does it. And to see whether we should check for updates, we run this query. And if there isn't one currently executing and it's been 2 hours since the last one, we run a new one. The problem is that the query says that there's one currently executing. So we never bother checking for updates. So this customer couldn't update to the newest version. Raven thinks everything's fine. Raven thinks its index is up to date. It thinks there are 0 stale indexes, there's 0 errors in producing indexes, there's 0 background tasks it has to do. So Raven thinks everything's fine, it's just not updating this index. So the error reporting is pretty terrible, and there's serious bugs like this, which will impact your customers. But apart from that, it's a really, really nice database. It's just a shame that there's this kind of thing there. Cool. And that is the end of the talk. If you want to know more, come find the Deployment Manager team, or indeed there's Dacon in this blog post, which goes into a bit more detail. Cool. Questions?
Raven versus Mongo, advantages, disadvantages?
They're very different. So we love the MapReduce indexes. We have a whole bunch of computations so that when the user comes to a page, we can give them instantaneous things. So the dashboard is all MapReduced. Which deployments you should roll back to is quite a complicated MapReduce index, which Mongo doesn't support. That Forbes was telling me that he'd done something so that he'd written his own kind of MapReduce thing on top of Mongo, which runs the indexes on a regular basis and stashes them in the database so that you can then query them, which essentially is what Raven is doing. And then you get all the latency of updating them. So I've not used Mongo, but it does have some features that Mongo doesn't. On the other hand, there's also the flip side of the coin, which is Mongo has features this thing doesn't as well. So.
What's the licensing?
The licensing is very complicated. It took my project manager, how long, Chris? Yeah, the licensing is very complicated, mainly because we're a pretty unusual case in that we're an ISV, so our product is a shrink-wrap thing, and we put a RavenDB server in there as well, so that's why it was more complicated for us, but it's quite complicated to understand. I think that's been made a lot simpler now as of some of the newer releases, but a long time ago, as a lot of the project, it was quite hard to understand.